Friends, we were dealing with the effect of dipole moment to the whole molecule. We have seen about the inductive effect and the mesomeric effect. These two effects create the permanent polarization in the molecule because of the presence of either an electron donating or an withdrawing group. In case of inductive effect, the effect is transmitted through the sigma bonds or sigma electrons, whereas in case of mesomeric effect, it is transmitted through the pi bonds which are in the conjugated system. Inductive effects fades away with distance, whereas mesomeric effect do not fade away with the distance. That are the unique features of these effects. Mesomeric effect is also called as conjugative effect, or it is also called as resonance effect. Today we deal with another effect which brings the permanent polarization in the molecule, that is hyperconjugative effect. This effect is also called as no bond resonance effect. Here, hyperconjugative. We have seen conjugative effect in the last presentation where the effect is transmitted through pi bonds. In case of inductive effect, it is transmitted through sigma bonds. In hyperconjugative effect, what is the way it transmits the polarization? Let us look into it. This hyperconjugative effect refers to the delocalization of electrons with the participation of the bonds of primarily sigma character. This occurs in the system where the carbocation is linked with an unsaturated system. Here, if I take this molecule, it dissociates into corresponding chloride anion and a carbocation. The carbocation adjacent to it there is a unsaturation. Adjacent to this there is an alkyl group. To satisfy this positive center of the carbocation, the pi electrons on the adjacent carbon in the unsaturated system moves towards this carbon and the pi electrons shifts. When these electrons shift to this position, the carbon here loses its electrons. That's why it becomes electron deficient, forming a new carbocation. This occurs because of the fact that this is a primary carbocation which is attached to one carbon. When this electron shifts, this carbocation which is formed is combined with two carbons. That's why it's a secondary carbocation. It is more stable. Always the reaction intermediates try to stay in the most stable form. To satisfy this carbocation center, the carbon hydrogen bond breaks and this sigma electrons moves towards this carbon to satisfy the carbocationic junction. The carbon hydrogen sigma bond is broken here. That's why the bond which was here has got disappeared. That's why it is called as no bond resonance effect. I'll get this molecule along with the H plus. It should have alpha carbon. This is alpha carbon. It should have hydrogens. Then only the hyperconjugative effect is seen. In hyperconjugative effect, both the pi electrons and the sigma electrons are involved. That's why it is hyperconjugative. If only pi electrons are involved, it is conjugative effect. If only sigma electrons are involved, it is inductive effect. If both pi electrons and sigma electrons are involved, it is hyperconjugative effect. If instead of Cl here, Cl is an electron withdrawing group. As it withdraws the electrons, this becomes a positive center. When this positive center is there, to satisfy this positive center, the pi electrons moves, creating a secondary carbocation. To satisfy the secondary carbocation positive center, the carbon hydrogen bond breaks and this electrons moves and it causes no bond resonance effect. There is resonance effect because of the pi bonds adjacent to the electron deficient carbon, and adjacent to this unsaturation, there is a carbon which is having free alpha hydrogens, and the carbon hydrogen bond breaks, the sigma bond breaks, and it forms conjugation with the adjacent carbon. That's why it is having hyperconjugation. Here both the sigma electrons and pi electrons are involved in the stabilization of the electron deficient center or the carbocation, and that's why the molecule gets stabilized, creating the permanent polarization in the molecule. Now we can appreciate the combination of pi and sigma electrons and its stabilization. Hyperconjugation effect is seen when the sigma electrons of CH bond is in conjugation with the p orbital of sigma or pi form. Here is a when the electrons pi electrons moves to adjacent carbon, the p orbital of this adjacent carbon becomes vacant and the carbon hydrogen bond breaks and the p orbital of the adjacent carbon forms bond with the p orbital which is empty. That's why it is called as hyperconjugation effect. The sigma electrons from the CH bond of an alkyl group interacts with the unsaturated system or an atom with a lone pair of electrons. That's why it is hyperconjugative effect. Another effect which we see here is a electromeric effect. The electromeric effect, unlike this hyperconjugative or inductive or resonance effect, is not permanent polarization which is created. It is a temporary polarization created in the molecule. This I call it as Mahesh Babu effect. This is a temporary polarization that is created at the seat of multiple bonds in a molecule in the presence of an electrophile. What is an electrophile? As we know, electrophile is an electron deficient species. It's a multiple bonds. An alkene, a compound containing a multiple bond or a molecule containing a multiple bond. I take an alkene. When it comes in the presence of H plus, which is an electrophile, as this is electron deficient, the pi electrons in the ethene or alkene moves towards one carbon which is nearer to H plus. When these electrons moves towards the one carbon, this carbon gains electron. Once this gains electrons, this becomes electron rich. Once these electrons are lost, what happens to this carbon? This becomes electron deficient. That's why polarity is induced. That's why this carbon becomes electron rich and this becomes electron deficient. A polarization is created. And as soon as the H plus is removed, it comes back to normal. That's why it is a temporary polarization that has got created in the presence of an electrophile. It is something like I am discussing about chemistry and Mahesh Babu or any other star actor who is very smart comes in front of you. What will you do? You leave me and turn towards Mahesh Babu. And that's why polarization occurs between you and me. Okay, you move towards Mahesh Babu, you turn your heads towards Mahesh Babu. Or, but Mahesh Babu should turn his head towards you, no? Okay, you will also turn, you will say hi, and you will go away. Then you will comes back to normal. This is a electromeric effect, which is a temporary polarization. This occurs in presence of an electrophile. Electrophile here is Mahesh Babu and alkene is you, where there is polarization. This is another effect which we see in presence of an electrophile. In the next, we deal with other aspects of organic chemistry. Till then, have a nice day. Thank you.